And this is section 6.1, and it's talking about the polygons, okay? So, um, as you know, the polygon is, what was the polygon?
A close side figure with at least 3 sides.
There you go. It's an enclosed figure with at least 3 sides. And the names, make sure you memorize all the names. You have them on the table. So here we have 3 is triangle, 4 quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 11 was what? Endecagon or ondecagon. And 12 was what? Dodecagon. Okay, so on it comes from uno and do comes from dos, so it's Latin root. And then deca was, what was deca? 10. So it's 2 plus 10, gone is side, so it's 12-sided figure. 1 plus 10, it was 11-sided figure. Okay, so memorize all of those. And then after that, we said that like for 13, what's going to be the name? 13th gone. That's right. And then 14th gone, and so on and so forth. Now we also need to, you have a highlighter, so you may use a highlighter. Let me see if this works. Okay, so then you have a side on a polygon, you have a side. My goodness. The side, this is the side. Like this is a 4-sided side polygon, and you have the vertex. The vertex is formed with 2 sides joining together. That's a vertex. And the diagonal connects 2 vertices. Okay, so this is a diagonal right here. So a regular polygon, what is a regular polygon? Okay, let me see.
And do we highlight all 3 of them?
You could, I just wanted for you to point that out. What I want you to highlight is this right here. A regular polygon, this is so thick. Let me change that too. A regular polygon, so thick. Okay, so a regular polygon is, let me just do like this. It's that polygon that has that has all the sides congruent, but also all the angles congruent. So all sides congruent and all the angles congruent. A polygon is convex, and I don't know if you remember that I covered this in December. I mentioned this. Convex means that all the diagonals would lie inside, in the interior of the polygon. And concave is when you have all or part of at least one of the diagonals in the outside of the polygon. Okay, so regular, all sides and angles congruent. Irregular, not all sides and angles congruent. So if you look at number on the first example, this is a regular because you have all the sides congruent and all the angles congruent. You know, all the angles are congruent. Here you go. Now, it's convex because if I draw the diagonal from one of the vertices or from the second vertex to the opposite corner, the diagonals, they all lie inside the polygon. Now, irregular and convex on the second one. Why irregular? The angles are not congruent, right? Because the sides are. So see, notice that these 2 angles are congruent to itself, but these 2 are different. So you have different angles. The angles are not the same. The sides are, but not the angles. So that's why they're irregular. It's an irregular figure. Convex, well, convex because the diagonals, if you draw the diagonals, both of them are going to lie inside the figure. So that's why it's convex. Now the next example, it's an irregular. How come it's an irregular? No, the sides are different, the angles are different. That's right. How about concave? Why are they concave?
Inside.
It goes like a cave, right? Inside. But also talking about the diagonals, if you connect those two vertices, that one diagonal is going to be outside the figure, and that makes it a concave. Okay, so if you have part of one, at least one of all the diagonals are outside, then it's a concave. Okay. Now, so let's classify the bottom examples. So for number 1, tell whether it's a polygon. If it is, then name it. So is number 1 a polygon?
Yes.
And what type of polygon? It's a pentagon. Pentagon. Number 2, is that a polygon? Yes. What's the name of that? How many sides does it have? 7. So the name of that must be heptagon. Why is it that 3 is not?
Because there's a curve.
There's a curve. That's right. So if it's a curvy side, one of the sides that forms that figure, it's curvy, it's a circle, semicircle is, this is kind of like from an ellipse, right? So not a polygon.
So what if it has like 3 or 4 sides that they have sides and then it has like
And
a curve?
little piece, then it's not a polygon. Yes, okay. Good question. Okay, number 4. In number 4, we have tell whether the polygon is regular or irregular. So that's one thing that we need to mention. And also tell whether it's concave or convex. That's the second thing. Hi. Oh, how nice. So you were saying that number 4 is, it's irregular and convex. That's right. How come it's irregular?
Because the angles are different.
Not all sides are the same, and also the
The sides angles.
angles. Yeah. Sides are different, angles are different. So it's irregular. And concave or convex? Convex. And is convex because there's no caving in, right? Or also all the diagonals would be within the figure. How about number 5? Regular or irregular?
Regular.
This is regular because all what? All sides congruent and all angles congruent, right? Okay, how about concave or convex?
Convex.
Convex. Even though here we don't have a diagonal, it's not caved in. How about 6? That would be
Irregular.
irregular and
Concave.
concave. And it's concave because you can see that little cave. Right, concave. And also,
And the sides and angles are different.
right, if you draw the diagonal from these two vertices, that's going to be outside. Okay?
Well, 2 of them are the same, one of them is different.
That is right. 2 of them would be inside, but another one would be outside. Yes. Okay, perfect. Let's move on now to the activity. So if you're watching this video, go ahead and open up the other video with the activity, please. So here, what we're going to do is, okay, so the formulas are, for the sum, it's right here, I'm going to use n minus 2 times 180. If I want to know the sum of the outside angles, this is the exterior angle, that's always going to be 360. But if I want to use only, I want to get one outside angle, so it's 360 divided by n. So those are the formulas that we need to make sure we know. So on number 7, it says, what is the sum of the interior angles in a pentagon? Okay, so interior angle sum is supposed to be, I need to wake you up. This one, right? Yes, I know. So if I want to know that sum, I need to use the formula. So what's the formula? N minus 2 times 180. So n is pentagon 5. You're right, you're right. No, no, no. Don't believe in me. Here you go. You're right. So believe in yourself, okay? So you're right. Pentagon is what? 5. I'm looking at the 7. I'm sorry. So it's 5 minus 2 times 180. So 5 minus 2 is 3. 3 times 180 is 540. Awesome. Okay, how about for an octagon? How many sides is an octagon? 8. So it's 8 minus 2 times Okay, so then it's 6 times 180. 1080? 1080. That's the sum of all the angles in a pentagon. In a nonagon, that is a 9. That is right. So it's 9 minus 2 times 180. How many degrees is there? 1260. Perfect. Okay, so that's the sum of all of them, right? And these are regular polygons. Now, what about if they just want one inside angle? Well, get the sum and then divide it by, since it's a regular, by the number of angles that you have. So if it's a pentagon, and you get the sum first, which is, what was the formula? N minus 2, it's an inside. This is an inside. The 360 divided by n is the outside. N minus 2 times 180 pen. There you go. So we already have the sum, right? 5 minus 2 times 180, and then divided by 5, we had 540, and divided by 5, each one of the inside angles would be 108. 108. How about if it's a heptagon? Well, get the sum first, which is n minus 2 times 180, then divided by 7, right? So what is 900 divided by 7? And that was the fourth row. What did you get? You had 128.57. Perfect. How about a 15th gon? Same thing. Get the sum first. 15 minus 2 is 13 times 180, then divided by 15.
It's 100, isn't it 15?
Right, because 15 minus 2 is 13. But I just put in 13. 156. Perfect, thank you. So whenever you find the inside, get the sum divided by the number of angles, and you get the inside. If it's the outside,
It's 360 divided by
the number of sides. And in a quadrilateral is
4.
4. So what is the sum of the outside angle? 90, right? 90. If it's an octagon, is 360 divided by 8, and that is 45. Perfect. If it's, well, that's it. Okay, questions about how to find the inside, outside, exterior, interior. So far, so good? Okay. So then on the homework, there's going to be some problems in which you have x's. Just think about, get the sum of all the inside angles, add all the x's, let it that equal to the sum, and then find the x. Come back and just plug it in. Okay, so that's for the homework. The second worksheet, that's right, yes. So at the bottom, where you have the x's, just get the sum of the angles inside, get that equal to all the x's together, and then you find your x first, okay?
Wait, where are the S's?
The last 3 problems, you know how you have 3 problems with x's?
Yes.
2 of them, you get the sum of the inside angles. Let the sum equal to all the x's together, find the x, and then come back and plug it in. In the outside, the sum of all the outside angles is 360. Then get 360 equals to all the sum of all those angles. And that would be able to finish that up, okay? Now, the last thing I need